Hello guys, welcome to Notebook Mathematics. This is video session 1 for class 8th and we will start from chapter number 1, that is rational numbers. So coming to introduction part, as we have seen in class 7 that rational numbers definition is rational number, a number in the form of p by q, means something will be in the numerator part, something will be in the denominator part, where p and q are integers, means these two numbers are integers. Integers means the numbers which contain positive numbers, negative numbers as well as 0, where p and q are integers and q value should not be equal to 0, right? So this denominator should not be equal to 0. Some of the examples we have written here, minus 7 by 8, right? So p value is minus 7, q is 8. So both are integers and q value is not equal to 0, that is this is not equal to 0, this is 8 here. So this is our rational number. Like that only 4 by 5 is a rational number, 1 by 3 is a rational number, minus 2 by 7 is a rational number, and so on. There are so many rational numbers, right? So only two things we have to keep in mind, that is both p and q should be integers. That means both numerator as well as denominator should be integer and the denominator value should not be equal to 0, right? So our next topic is properties of rational number. So there are a lot of properties, like we have seen properties in natural number, properties of whole number. Now we will see the properties of rational number. So first property is closure property, right? First property is closure property. So what is closure property? Closure property is we will take any two numbers and we will check on addition that two numbers are rational number or not. That means we will take two rational numbers and we will apply addition and we will find out that whether the two numbers are still rational number or not. The same procedure we will apply for subtraction, for multiplication and for division, right? So suppose that 4 and 3 are two rational numbers, because I can write them as 4 upon 1 and 3 upon 1. Keeping 1 in the denominator will not change the value, because 1 divided by 4 will be 4 only. So first we will take any two numbers and these two numbers are rational number and we will apply addition, subtraction, multiplication and division and find out whether these two numbers will still be rational number or not, right? So for addition, the answer is 4 plus 3, that is 7, and denominator is 1 only. Taking LCM we will get 1 only. So that is why I have taken an easy example, right? So this is also a rational number, and thus I can say that for any two rational number, that is for any two rational number a and b, a plus b is also rational. Clear? For any two rational numbers a and b, a plus b is also rational. And similarly we will check for subtraction. So 4 minus 3 is 1 upon 1. So here you will get 1 upon 1, that is p value is also integer, q value is also an integer value. So and q is not equal to 0, therefore it is also a rational number. Right? And there is no exception case. So I can say for any two rational number a and b, a minus b is also rational. Now I will come to multiplication part. So 4 by 1 multiply by 3 by 1. So multiplication is straightforward, that is numerator to numerator and denominator to denominator. So 4 3s are 12, 1 1s are 1. Again it is a rational number. So from here I come to know that for any two rational number a and b, a multiply b is also rational. Now coming to division part, if I write like this, 4 by 1 divided by 3 by 1, right? So for division we are changing it to multiplication, and this number over right hand side of a division will be reciprocal. So I will get here 4 1s are 4, 3 1s are 3, the same rule of multiplication. So you will get 4 by 3, which is again a rational number. So from here I can say division is also rational. That is, sorry, division is also following the closure property. So why I have put a cross mark over here? The division is not following closure property. So we will understand this by dividing a rational number 4 by 0. Now, if I will change this divide sign will change to multiply. 0 is also rational number, right? And here I can keep denominator 1. I told you for any number we can keep denominator 1 and its value will not be changed. Now the reciprocal of this will be 1 upon 0. 4 1s are 4 and 0 1s are 0. Now as I told you in the previous section that rational numbers are numbers which are in the form of p by q, right? P, that is numerator part, is an integer. Q, that is denominator part, is also an integer. So both are integers, but q value should not be equal to 0. So here q value we are getting as 0. So it means that this is not a rational number. It means division is sometime following closure property, where sometimes it is not following closure property. So permanently we cannot say that division is always following closure property, right? So that is why division is not closed. A divided B is not always rational, right? Is not always rational. Coming to the second property, that is commutativity. So as per this property, suppose that A and B are two rational number, then addition of those numbers in any order, subtraction of those numbers in any order, multiplication of those numbers in any order, or even division of those numbers in any order should not change the result. That means for addition, if I write like this, A plus B, I am adding the two numbers in any order, or B plus A, the value which I will get should not change. That means the result should be same. Then we can say that the two rational numbers are following commutativity, right? So let us see this by an example, taking again A value as 4 by 1 and B value as 3 by 1. These are my two rational numbers, right? So I will first find out A plus B. So 4 by 1 plus 3 by 1. So 4 plus 3, it is 7 upon denominator is same. So it is 7 by 1. Now I will try to find out B plus A. So B value is 3 by 1. A value is 4 by 1. So 3 plus 4 is 7 and denominator 1. Clear? So I find that my both results are same. This means that addition of two rational number in any order, that is whether B is added to A or A is added to B, the result is same. So therefore I can say that addition is commutative. That is A plus B is equal to B plus A. Right? Now if I come to subtraction part, I have to check A minus B is equal to B minus A or not. The same rational numbers I will again take, 4 by 1 minus 3 by 1, and here I need to check 3 by 1 minus 4 by 1. Since denominators are same, I will not take LCM. That is why I will choose this example, right? So the denominator part will be 1 only. 4 minus 3, it is 1. Here denominator part will be 1 only, 3 minus 4 it is minus 1. So can you say this value is equal to this? No, because numerator part of both the numbers are different. So these are not equal. So therefore subtraction is not commutative. That is a minus b is not equal to b minus a. Now coming to multiplication part, I have to check a multiplied by b is equal to b multiplied by a or not. So I will again choose the same numbers and try to find out whether these values are same or not. So first 4 3s are 12, 1 1s are 1. Here 3 4s are 12, 1 1s are 1. So I can see my both values are same. So I can keep here equals to sign. Right? Both values are same. So from here I can say that multiplication is commutative. That is a multiplied by b equal to b multiplied by a. Now we have to find out our last one, that is division. So for division I have to check whether a divided by b is equal to b divided by a or not. This only we have to check. If it is so, then division will be commutative. So I will keep the value 4 by 1 divided by 3 by 1, and here 3 by 1 divided by 4 by 1, and I have to check whether these two values are giving me the same result. That is, I have to check whether the result is same, then it will be equal. If the result is not same, then they will not be equal, right? So for division, we are changing the division sign to multiply and the reciprocal of the right hand side part of division. Similarly, I have to do here also, division sign will change to multiply and the reciprocal of this. So here I am getting 4 divided by 3. Here 3 ones are 3 divided by 4 ones are 4. 4 by 3 is not equivalent to 3 by 4. 4 by 3 means, if suppose this is my circle, right, which contains 3 parts, right, these 3 parts are full, and one more circle which contains 3 parts, right. A circle is of 3 parts. Out of these 3 parts are there and one more part is there. So this is my 4 parts of 3 parts circle, and this one is total 4 part circle is there. Out of these 3 parts are shaded. So can you say these two are equal? This one contains one circle full, and in the other circle one part is shaded out of 3. Here one circle is also not complete. It means these two numbers are not same. So division is not commutative. That is, a divided by b is not equal to b divided by a. Associativity property. So this property is for 3 rational numbers, that is, for any 3 rational numbers a, b, c, we have to find out whether if 3 rational numbers are added in any order or subtracted in any order, or multiplication is done in any order, or division is done in any order, then the result is remaining same or not. So coming to our first topic, that is addition, we will take example. Now I will take a value as 4 by 1, b as 3 by 1, and c as 2 by 1, right? And first I will try to add these 3 numbers in any order. That is, first I will add a with b, and then to the result I will add c, and then I will try to add b and c first, and to the result I will add a, and I will try to find out whether these both are equal or not. So keeping the values, in place of b 3 by 1, in place of c I will keep 2 by 1, here also 4 by 1, In place of b I will keep 3 by 1 and 2 by 1. So first we need to add this. So answer is denominator will be same, 7 by 1 plus 2 by 1. Here I need to add this first. So here denominator will be same, 5 by 1, clear? And this part will be as it is. Now we'll check here, the denominator will be same, 7 plus 2 that is 9 by 1. Here also the denominator will remain same, 4 plus 5 that is 9 by 1. Since my both results are same, so I can say that addition is associative. So addition is associative, that means a plus b plus c. In first case I have taken a plus b first, and then to the result I have added c, and then it is equal to a plus b plus c, in which b plus c I have added first and to the result I have added a. So addition is associative and it is following the procedure. Now next one, to subtraction we need to check. In the same way, if I will subtract the numbers in this order, I need to find out whether subtraction is associative or not. So a minus b minus c, a minus b minus c, and I will write the numbers. First we will solve this. So denominator will be same, 4 minus 3 is 1. Here also the denominators will be same and 1. So here the denominator will remain same, 1 minus 2 is minus 1. Here the denominators will remain same, 4 minus 1 is 3. So comparing this, I can find that my both answers are not same. One is minus 1, one is 3. So I can say that these results are not equal. It means subtraction is not commutative, not associative. It means a minus b minus c is not equal to a minus b minus c. First we have done this, then we have done this. But we find that both the results are not same. It means subtraction is not associative. Clear? To check whether multiplication is associative or not, so we will first write three numbers a, b, c. We will put multiply sign between them. On the other hand also we will write three numbers a, b, c and put multiply sign between them. But in the first case we will multiply these two numbers. In the second case we will multiply these two numbers first. And then to these two numbers we will multiply the result. Right? So proceeding as in the previous example, a value was 4 by 3, b is 3 by 1 and c is 2 by 1. A is 4 by 1, b is 3 by 1, c is 2 by 1. And now we have to multiply this part first. So 4 3s are 12, 1 1s are 1, multiplied by 2 by 5. Here 3 2s are 6, 1 1s are 1, here 4 by 1. Now multiplication, so 12 2s are 24, 1 1s are 1, 4 6s are 24, 1 1s are 1. So I find that my both results are same. It means multiplication is associative. Now we will find out for division. Right? First we have to find out for these two numbers, then for these two numbers, and to the result we will divide with this number. Right? So 4 by 1 divided by 3 by 1 divided by 2 by 1. 4 by 1 divided by 3 by 1 divided by 2 by 1. For division I told you procedure. First number will remain as it is. We will change this sign to multiply and reciprocal of this. Divide by 2 by 1. Similarly, here also the first number will remain as it is. Divide will change to multiply and this number will change to its reciprocal form. So 4 1s are 4, 3 1s are 3, divide by 2 by 1. Here divide as it is, 3 1s are 3, divide by 2 1s are 2. Now again reciprocal of this. sorry, reciprocal of this number 1/2, that means this number will change. Similarly this will be 4/1 multiplied by reciprocal of this, that is 2/3. So here 4 1s are 4, 3 2s are 6, here 4 2s are 8, 1 3s are 3. If I change it to lowest form, 2 2s are 4, 2 3s are 6, what I find, this is, if a circle is there, right, if a circle is there of 3 parts, out of this it contains 2 parts. If a circle is there of 3 parts, then this contains 8 parts. That means a circle of 3 part completely, a circle of 3 part again complete, total 8 are there. In the third circle of 3 part, it will contain 2 part, total 1 2 3 4 5 6 7 8. That is 8 parts in a circle of 3. So this part is only one circle having 2 parts out of that 3 part circle, whereas this is a circle of 2 circles of 3 part and a circle of 3 part which contain 2 more parts. So clear it is, this number is more than this. So from here I can say that these both numbers are not equal. It is that multiplication of numbers is following associative property, whereas division of 3 numbers is not following associative property. From our previous examples we can say that multiplication of 3 numbers is following associative property, whereas division of 3 numbers is not following the associative property. Clear? Coming to our fourth important property, that is identity element 0 for addition. So here identity word means if we will add any number to our rational number, the value should not change. Suppose that a is our rational number, and if I add any number, so answer should be a only. Suppose that, for example, we have taken in our previous example a value 4/1. If I add something to it, the result should be 4/1 only. That means चलो 1 हटा देते हैं, 4 में आपको कुछ ऐड करना है और आंसर 4 ही रहना है, सो 0 है, यानी 4 में आप 0 ऐड करोगे तो 4 ही रहेगा. देखो 1 2 3 4, 4 में आपको 0 ऐड करना है, कुछ भी ऐड नहीं किया आपने, तो आंसर क्या होगा 1 2 3 4. इसका मतलब 0 जो है एक ऐसा नंबर है जो आइडेंटिटी एलिमेंट है, यानी किसी भी रैशनल नंबर की आइडेंटिटी बना के रखता है जब वो उसमें ऐड हो जाता है. यही एग्जांपल अगर हम देख लेते हैं 2/3 में, ये भी एक रैशनल नंबर है और इसमें हमने 0 ऐड किया तो क्या होगा, ये नंबर चेंज नहीं होगा क्योंकि 0 किसी भी नंबर में ऐड होता है तो वही नंबर रहता है. सो आंसर विल बी सेम. दैट मीन्स द आइडेंटिटी ऑफ दिस नंबर विल नॉट बी लॉस्ट. सो 0 इज द नंबर विच when added to this number, so its identity will not be lost. Therefore it is called identity element 0 for addition. Similarly identity element 1 for multiplication. Suppose that a is any rational number और मैंने कहा कि इसमें कुछ नंबर मल्टीप्लाई करना है कि आंसर a ही रहे. ऐसे ले लेते हैं इसको, 4 कोई रैशनल नंबर है और उसमें कोई नंबर मल्टीप्लाई करना है और आंसर 4 ही रहना चाहिए. सो 1 है, 4 1s are 4, 3 कोई रैशनल नंबर है तो 3 1s are 3, 2 कोई रैशनल नंबर है 2 1s are 2, राइट. सो वैसे ही कोई भी नंबर अगर हम देखें तो उसमें अगर 1 मल्टीप्लाई किया जाए तो उसकी आइडेंटिटी लॉस्ट नहीं होती और वो आंसर वैसे का वैसा ही रहता है. सो 1 इज एन आइडेंटिटी एलिमेंट फॉर मल्टीप्लिकेशन एंड 0 इज आइडेंटिटी एलिमेंट फॉर एडिशन. क्लियर? 6th प्रॉपर्टी पे, नेगेटिव ऑफ अ नंबर और एडिटिव इनवर्स. तो कोई नंबर ले लिया मैंने 4 और मैंने कहा उसमें कुछ ऐड करना है ताकि आंसर हो जाए 0. समझ आ रहा है? जैसे a कोई नंबर है उसमें कुछ मुझे ऐड करना है तो आंसर हो जाना चाहिए 0. तो सिंपल है, 4 में आप -4 कर दीजिए, यानी इसका इनवर्स, ये +4 है तो आप -4 कर दीजिए, तो क्या होगा यहाँ पे 4 प्लस माइनस माइनस 4, 4 माइनस 4 क्या हो जाएगा 0। या अगर सिंपल कहूँ तो अगर a है तो आप यहाँ पे माइनस a रख दीजिए तो आंसर हो जाएगा 0। अगर माइनस a है तो उसमें आप प्लस क्या करेंगे तो 0 हो जाए, माइनस a है तो आप प्लस a कर दीजिए उसमें, तो आपका आंसर आ जाएगा 0। यही होता है एडिटिव इन्वर्स, यानी अगर किसी नंबर में उसका इन्वर्स नंबर जोड़ दिया जाए, जैसे 4 में हमने -4 जोड़ा, इन्वर्स नंबर, ठीक उसका उल्टा साइन के साथ वही नंबर, यानी +4 है तो -4, और अगर इन्वर्स नंबर उसमें ऐड कर दिया जाए तो आंसर क्या हो जाएगा 0, राइट। अब देखते हैं रेसिप्रोकल और मल्टीप्लिकेटिव इन्वर्स। ऐसा ही कोई नंबर मैंने ले लिया 4/1 और इसमें मल्टीप्लाई कर दिया इसका इन्वर्स। इसका इन्वर्स क्या होगा, 4/1 है तो 1/4, क्लियर। 4/1 है तो 1/4, उसका क्या हो गया रेसिप्रोकल, यानी हमने उसको क्या कर दिया रेसिप्रोकल कर दिया, यानी जो डिनोमिनेटर था वो न्यूमरेटर बन गया और जो न्यूमरेटर था वो डिनोमिनेटर। तो क्या होता है देखते हैं, 4 1 ज़ा 4, यहाँ 1 4 ज़ा 4, सो यहाँ 4 से 4 डिवाइड हो रहा है, 4 1 ज़ा 4, सो आंसर इज 1। यानी अगर कोई नंबर a है और उसको हमने मल्टीप्लाई कर दिया उसके रेसिप्रोकल से, दैट इज 1/a से, तो आंसर क्या आ जाएगा 1। दैट मीन्स रेसिप्रोकल और मल्टीप्लिकेटिव इन्वर्स जो है किसी नंबर का, वो आपको आंसर क्या देता है 1। लास्ट प्रॉपर्टी, डिस्ट्रीब्यूशन ऑफ मल्टीप्लिकेशन ओवर एडिशन फॉर रैशनल नंबर, यानी मल्टीप्लिकेशन ओवर एडिशन, एडिशन के ऊपर हमको क्या करना है मल्टीप्लिकेशन करना है, तो उसमें नंबर डिस्ट्रीब्यूट हो जा रहा है। जैसे देखिए a मल्टीप्लाई बाय b प्लस सी, तो हमने क्या किया a को पहले b से मल्टीप्लाई किया है, फिर a को मल्टीप्लाई किया c से, और ये जो बीच में एडिशन था वो एडिशन यहाँ अप्लाई हो गया। तो इसका एक एग्जांपल देख लेते हैं, आपको इजीली समझ आ जाए। जैसे ये रिजल्ट और ये रिजल्ट हम अलग अलग लिख लेते हैं, a मल्टीप्लाई बाय b मल्टीप्लाई बाय सॉरी b प्लस सी, यही तो लिखा है हमने मल्टीप्लिकेशन ओवर एडिशन। और यहाँ हम चेक करेंगे a मल्टीप्लाई बाय b और a मल्टीप्लाई बाय c करेंगे, और उसको हम दोनों रिजल्ट्स को हम ऐड करेंगे और देखेंगे अगर आंसर सेम है तो ये जो रिजल्ट हमें दिखाया गया ये करेक्ट है। सो a की वैल्यू 4/1, b की वैल्यू 3/1 और c की वैल्यू मैंने ले ली है 2/1। ये मेरे एग्जाम्पल के लिए मैंने कंसीडर कर लिया है। वैसे यहाँ पर भी a जो होगा वो क्या होगा 4/1, b जो होगा वो होगा 3/1, वैसे a यहाँ पर क्या था 4/1 और c जो है वो क्या है 2/1, और ये दोनों जब रिजल्ट आएंगे मेरे, उन दोनों को मुझे ऐड कर देना। सो आई विल चेक दिस। सो 4/1 मल्टीप्लाई बाय, पहले हमें ये ब्रैकेट सॉल्व करना है, डिनोमिनेटर विल बी सेम, 3 + 2 आई विल गेट 5। अब इनको मल्टीप्लाई करना है, सो 4 5 ज़ा 20 एंड 1 1 ज़ा 1। यहाँ क्या हो रहा है, यहाँ पे हमें पहले ये ब्रैकेट सॉल्व करना है, 4 3 ज़ा 12, 1 1 ज़ा 1, प्लस यहाँ ये ब्रैकेट सॉल्व करना है, 4 2 ज़ा 8, 1 1 ज़ा 1। सो डिनोमिनेटर पार्ट सेम है, एडिशन करना है, एडिशन, सो क्या होगा 12 + 8 20। तो मैंने यहाँ देखा मेरे दोनों रिजल्ट जो है वो सेम आ रहे हैं। इसका मतलब कि ये जो डिस्ट्रीब्यूटिव प्रॉपर्टी है वो इस एग्जाम्पल से हमने सॉल्व कर ली, और यहाँ से हमें क्लियर हो गया कि अगर कोई रैशनल नंबर a है और उसको मल्टीप्लाई किया गया ओवर एडिशन ऑफ 2 रैशनल नंबर, यानी ये 2 रैशनल नंबर b और c के एडिशन के ऊपर हमने मल्टीप्लाई अप्लाई किया है, तो जो फर्स्ट रैशनल नंबर है वो क्या होगा इंडिविजुअली एक एक नंबर से मल्टीप्लाई होगा और उनके बीच का ऑपरेशन बाद में उनके बीच लग जाएगा। जैसे a यहाँ पर b से मल्टीप्लाई हो रहा है, a यहाँ पर c से मल्टीप्लाई हो रहा है, और उनके बीच एडिशन जो ऑपरेशन था वो उनके बीच में अलग से लग गया, राइट। इसी तरीके से यहाँ भी ये एक रिजल्ट दिखाया गया है जो क्या है डिस्ट्रीब्यूशन ऑफ मल्टीप्लिकेशन ओवर सब्ट्रैक्शन। तो ये आप एग्जांपल लेके चेक करिए, ये काफ़ी इजी है। इन प्रॉपर्टीज़ को थोड़ा ध्यान रखिए, और ये प्रॉपर्टी जो है वो काफ़ी ही इम्पॉर्टेंट प्रॉपर्टी है जो हम एक्सरसाइज के अंदर भी यूज़ करेंगे। ये प्रॉपर्टी ऐसा नहीं है कि यहाँ से यहीं यूज़ होता है, ये प्रॉपर्टी यहाँ से ये भी यूज़ हो सकता है। यानी मैं आपको ऐसा भी दे सकता हूँ a मल्टीप्लाई बाय b प्लस a मल्टीप्लाई बाय c, तो क्या होगा यहाँ पर a कॉमन है दोनों में, तो a निकाल दिया गया और b प्लस c, तो ये है रिवर्स ऑफ दिस डिस्ट्रीब्यूशन प्रॉपर्टी। ऐसा भी यूज हो सकता है एग्जाम्पल के अंदर। सो काइंडली नोट डाउन ऑल द टॉपिक्स विच वर डिस्कस्ड इन दिस वीडियो सेशन।